Wait a minute, hold on 2 seconds here. Gentlemen, are you ready?
Yeah.
Gotcha. So according to my records here, Nico, you're on the team, correct?
Yeah.
What role did you have on the team, sir?
I was the user story scribe.
User story scribe. Fantastic. Addison, what was your role, sir?
Task
Task scribe, okay. Ian,
iteration planning.
iteration planning. Yamil,
Testing.
testing, okay, excellent. Mr. Carter,
I was the user.
the user?
Yes.
Excellent, fantastic, sir. All right, take it away, guys. Oh, by the way, what story are you doing?
Scenario 1, the first one, the driving school.
Driving school, all right,
Stop
excellent.
and go driving school. So the stop and go driving school needed to computerize their entire operations. So I needed a program that collected and stored the student's name, type of car, license number, plate number, type of ticket received, and their ticket ID number. When the student, upon receiving the ticket, had to successfully watch up to 4 videos and take up to 2 tests, depending on what type of ticket they received. So if they got there's 3 types of tickets that the stop and go program can handle: failure to stop, speeding, and driving without a license. Speeding is the most harsh, which would require you to watch 4 videos and take 2 tests. Failure to stop would require you to watch 2 videos and take 1 test, and driving without a license only require you to watch 1 video. The program is required to track the student's progress through the videos and tests. So for example, if a student watched a video and took a test, when you type the name of that student that's in the database, they would come up and it would show you how much progress they've made. When the student has completed their training, the program has to print a certificate for that student with the correct type of training they received. The program had to send an email to the state, which would give a receipt, the state would send you a receipt back, and that receipt would have to be stored on the student's record in the program.
And then comes me. So Thomas came to me in his time of need and was asking me to put together, or asking our team, I should say, to put together a code to produce what he's looking for. And so I got a chance to sit down with Thomas and interview him, and he told me what he wanted, and I broke it down to the stories that you see before you. I separated into the collecting the student's information from the license, the car, the ticket type, and all that stuff. I asked him if he planned to charge to take this school. He said yes. So then I created a user story in regards to taking credit card information, and I got the pricing from him per class. 20 for driving without a license, 30 for failing to stop, 40 for speeding. Then he was telling me that he wanted to display the progress of the student, print the certificate, receive this receipt from the state after sending an email out, and just updating it as the student goes along and completes the course. To read the ticket type, and be able to direct the student to the correct tests and video combination depending on the type of ticket they receive. And he also wanted me to add in that if it's not one of those 3 types of tickets, then produce an error message and ask to re-put in the ticket type. So that's essentially what we broke it down into. And then I met with the task scribe to do what's next.
Alright, so my job as task scribe was to take all the things that Nico gave me and turn them into more workable situations for those who were programming the code. And it breaks down each story into a detailed piece that can be coded for. So the first one we have here is charge $20, $30, and $40. $40 for speeding, because that is the most harsh. And Each one would take about 5 days at a priority level of 2. Our priorities are set 1 through 3, 1 being the most important, 3 being important but less important. And so after that, we moved on to collect students' name, car description, license number on their license ID, plate number, type of ticket, and ticket ID. And that was broken down into each one of those criteria. And we estimated about 1 day, 1 to 2 days for each of those, with a priority level of 1 on collect name and collect type of ticket, because those are pretty much the most important, was who it is and what they did. After that, the other ones would follow pretty shortly, along with ticket ID number, which had priority level 2. Alright, next we have the speeding ticket type is, if it's none of the 3 that were listed, then it would print out an error, and it would ask to re-input the ticket because obviously there was a mix-up and they don't have that, it was misread. So the first one on the priority level of 1, they all have priority levels of 1. The first one will take 3 days, the second one will take about 2 days, and the third one will take about 3 days. The first one we check and see if the type is speeding, we check the type of ticket it is. The next one we have to print out an error message. And the third one, we would have to actually request that they re-input the ticket, or else they might not input the ticket. The next one is to collect the credit card payment info and to take all classes, all the pieces of the credit card, and also accept all types of cards. So the first, to accept all pieces of the card, you have to take the input card type, MasterCard, Visa, etc. Input number on the card, the input expiration date, the security code on the back, and the billing address. Each one would take about 1 day. With a priority level of 2 through 3, they weren't the most important at the time. The ticket is the most important, so this would come after those. Alright, the next is the read ticket type and direct students to the corresponding video that they would have to take and tests. If the ticket type was speeding, the student must watch 4 videos, as he said at the beginning. And so each one of these took about 2 days. And we left with driving without a license as priority level 3 and not 2, just because that was kind of the least offense and wouldn't really need to be voted for immediately. The last one is display the progress of inputted student and print out how much student has to do if it's incomplete. And that would take about 3 days at priority level of 3. And the last one, print out a message if the student is complete, 2 days with a priority level of 3.
Alright, so now that those tasks have been given so now that we have those tasks that we can give the priorities and number of days to complete, it was my job to put them into iterations and make sure they all fit with roughly 1 month. Since the iterations are about 1 month, that means we've got 20 working days. And since no programmer is 100% efficient, I have to account for velocity. And since I have no experience working with this mysterious programmer, I have to just assume that we've got a velocity of 0.7. It's a nice rule of thumb, which gives us roughly 15 days in the iteration spent actually working. Which means from there, I have to take the tasks that are most important, make sure they get put in the first iteration. And once I've got all the priority one tasks, if there's any room left, which there was, I start putting in some priority 2 tasks. With all these tasks added together, they add 14 days of work, which is roughly 1 iteration. In the second iteration, basically the same process, but this time I left a little room on the tail end for testing. So that way, while we're working on the iteration 2 tasks, we can start testing the tasks we did in iteration 1. Again, add them all together, this time it adds up to 15 days of work in this iteration.
So for the testing, we, as a tester, when it started out with one of the most important piece, which is the credit card information. So for the credit card information, since it's the only piece in the whole program that will be interfacing with another program, specifically interfacing with MasterCard, Visa, to get the information, it was one of the ones that they should started with testing. So we estimated about 2 days testing for the credit card information. So for test, we would do, well, if I put a different number, if I put an incorrect number, would it tell me, would it give me an error message? If I do give the right number, would it give me a response that the payment information was received correctly? Where would it give the error? Would it be from our program, or would it be from MasterCard or Visa? And the second testing would be for check payment for each class. So after they input information, how much payment do I have to make? Is it gonna tell me what's the amount, $40, $30, or $20? Is it gonna charge it correctly? Is it gonna get the information back from MasterCard or Visa? Those are the two most important things to start testing, since it's not from our code, it's shared code between us and MasterCard Visa.
And then on the third iteration, we had enough room to get all the rest of the tasks that were priority 3. And then that left us about 9 days after, on iteration 3 to make sure everything works properly and everything comes together.
So for the last 4 testing, first thing we would test information collection. So is it inputting the names correctly? Can I put the names, not only letters, but is it going to accept numbers? Is it accept any other type of input, or is it show an error for that? Verify students take correct person videos after I input the ID. Is it showing, if I put an incorrect ID, that it is incorrect? Is it showing an error to write it back? After it gets the correct number for each type of ID number, is it giving me the correct course? Is it giving me the correct videos to watch? The amount of videos the test to take. Test error checking for ticket type. This one would be more time for it, since there could be a bunch of different tickets. There could be different types that needs to be checked individually for. And if I put a type of ticket that is not allowed, would it tell me this type of ticket is not allowed, and would it give me information who should I speak to, or where should I go to for that type of ticket? And trying to verify progress at various intervals. Is it added to display a progress of how much I have finished with the test, with different times of ending, with different types of tests, and sometimes videos I have to watch. Is it going to show me where I am correctly, accurately? Is it going to account for maybe less videos I have to watch, less tests I have to take? Is it going to account for those correctly? So those were the 4 things that we focused on for this iteration.
Is that it?
Yep.
Excellent. Do we have any questions for them on their driving school implementation? So a lot of your estimates for how long things are going to take seems a little bit high, right? So you're giving 2 and 3 days to get relatively simple functionality, right? It's like collect the username, 3 days. They're not giving you 3 days for it, right? Yeah. Well, no, actually for implementation, for the program, for the original estimates of the tasks. Or go back another one. Yeah, collect name, 2 days. I mean, if it's a big name, yeah, but come on, it's I mean, I want to be a programmer on that project, right? 8:30, I'm done with my task for the day, and I've got the next day off, right?
I think along with collect names, you would collect also other information about the person. It wouldn't just be name, that was a generic, basically a placeholder. Name along with birthday, things like that. Other things that would come along, I mean, that would also be included in the license ID number. But also, that's kind of a preliminary thing that you have to fill in and have before you take the class. So it was really just the personal information such as name. And we estimated about 2 days just in case there were some things that maybe we didn't think of or needed to add, that the next day we'd come back, add some more things that we needed to, but really just almost at the stage.
Gotcha. Once you go ahead and start.
Also, you'd also have to make sure that the name was actually a valid name. Like you couldn't just bash your keyboard and put like QA113 $. Like you have to make sure it would resemble a name. So there would have to be like exception.
I guess you might also be checking to make sure it's a valid driver's license, right? If it's some sort of lookup in another database or something like that. Okay, that makes sense. Now, also, after you have your first iteration out, you would assume that you'll start to have bugs, right? When would you work those bug fixes in?
So we put testing is after the first iteration, we get some codes done. The second iteration, we start testing there to test for different bugs and any errors that we could find.
And even then, like after the first iteration, we're going back to the user, and things are probably going to get reprioritized, and we're going to have to remake the iterations anyway. So based on how many bugs we have at the end of iteration 1, we can squeeze those in along with the refactoring of the entire iteration.
So you have enough room in your schedule to allow some of that to be taken care of in each iteration?
Yeah, we added a little bit of extra time into our iterations and the amount of time that we expected to be done with certain things. Because we wanted a few extra days in case something came up or the user changed his mind or, so we added, if you want to call it, cushion room for any necessary repairs that need to be made.
Questions? Questions? All right, good job, guys. Well done, very well done. So this is Team New York. On Team New York, we have Noah. Noah, what role will you be playing in today's presentation?
The tester.
So Noah's the tester. Excellent. Eli, what's your role?
The user.
All right, Eli's the user. Fantastic. Andre?
On the iteration manager.
Iteration manager. Sean?
I'm the task scribe.
Task scribe. Excellent. Fabulous. And we finally, Tristan, we get down to you.
I'm the user story scribe.
User story scribe. Excellent. Fabulous. Now we know what everybody's doing. Gentlemen, take it away.
So, as the owner of this beautiful new Krispy Kreme donut shop, it's a shame to see that people are turning healthy.
Eli, please remember, Krispy Kreme is a trademark name, and instead of Krispy Kreme, I think you're actually slightly different, aren't you?
What was on the paper? Wasn't it just
It wasn't Krispy Kreme. What was it, guys?
Creamy Crisp?
There we go. Thank you. Just once again, we have some trademark issues.
There we
We're trying
go.
to- Okay, there we go. All right. I appreciate that.
The donut shop.
There we go.
Oh, I forgot the fake name. But here at the donut shop, it's taken a turn since people have gotten healthy. So we have to turn it around ourselves and make these beautiful kale donuts. Beautiful. But I'm gonna need a new program to help me start this new business. So I'm gonna need some help with these user requirements right here. There's gonna be 5 of them. You wanna keep track of the kale supply, resupply the kale, then track the kale through the processes of making it into the donuts. Then I want an to be able to estimate how many donuts per hour I'm gonna have to sell or be able to sell before running out of that hour. And then to organize the sales of all the different types of donuts. Here we have the keep track of the supply. Like kale only has a 2-day lifespan, so I'll need help making sure that the kale I have in store isn't bad kale before I have to order new kale. Yeah, how much good kale there is and how much I need to sell. Forgot those were there for a second. Bam. Here, when we want to buy more kale, we want it when we just go under or have less than 1.25 tons. Because kale goes fast, it turns out. Very successful donut shop for kale. You're welcome. Eat healthy. But there's also going to be 3 stores that we want to buy from, but only if they're selling it at the best combination of cheapest and quickest delivery. But if it comes out to be a tie, instead of flipping a coin, I want it to be from the cheaper place. Because I'm a greedy business American. That's how we work, capitalism. Now, this new store implements a 10-step process. About 1 ton of kale goes through that process in order to make a donut. I want to be able to tell how much total kale is in that process and how much is in each of the different 10 steps. And then I want to be able, take each step. Yeah, and then I want to take from that 10-step process where I could see how much kale is in each process and be able to use that to somehow estimate the donuts per hour that I will be able to sell at my location. And then I want to organize these sales because here we don't have one type of kale donut, we have 9 types of kale donuts. Varieties for all tastes of kale. And I want to know how many of each of these donuts are sold and in what quantity they're sold when people come to get them. And that's about it.
Alright, so now we get to the user stories. I talked to our wonderful user over there and got to know exactly what he was wanting to do. So I wrote these beautiful stories about what we need. We have the massacre at the market. We have to decide which supplier to order our kale from. We have tipping the scales. We must keep track of we must keep the kale supply above the required amount. And we should always have some in reserve, just in case all of it just randomly disappears in the game. Because you never know. Kale just flies off the shelf, you know? We have the one ring to rule them all. We have to list each of our donut types and then find out how many of each were ordered. And then the game has reached a stalemate. Check how many kale, how fresh the kale supply is. If it's gone bad, just get rid of it. We have time for the price is right. Make a guess and estimate on our DPH, donuts per hour. Wonderful, very wonderful. And then we have trouble at the chocolate factory. We have to keep track of the kale going through the 10-step process of the donut transformation. It's very important. We must understand how it works. And then we have the stocker in the closet. Keep track of what each customer orders.
So I spoke to the user story scribe and broke it down into tasks for what he gave. So we have 4 different categories. The yellow task was the keeping track of the supply, keeping track of making sure that there's 10 times on hand or of reserve. And I broke them down into days. Those took about 9 days to complete the entire keeping track of the supply of kale. For the purple tasks, those are the tasks that chooses the supplier and what supplier we choose. That takes about 8 days, I believe, and that's tracking the fastest time, the delivery, and making sure that we order from the correct supplier. These green tasks, this is all tracking the steps in the process of the kale, tracking where the kale is, how long it's been at which step, and at which step in the process it is. That takes 12 days. I estimate 12 days to track that because that seems like a larger project, a larger piece. And then for these yours tasks, this is all about listing the types of donuts and then also making sure, tracking the orders as well as the donuts per hour, which is a big portion. And that takes about 13 days because that's also a very large project in by itself.
I spoke with Shauna to organize how we will plan our iterations and prioritizing each user story and task. And our company uses this dashboard, which is strangely familiar. I calculated the first iteration with 80% velocity, so we have around 16 days of actual work. And this is our first iteration. After our first iteration, I calculated a lower velocity because we had to keep in mind at the end of our second iteration, we wanted to make sure the bugs from iteration 1 were taken care of. So, in our final iteration, I calculated a little bit more time because over time our programmer was more efficient. And notice at the end again we took into consideration the bugs from the previous iteration.
Alright, so for testing, we're going to test after each iteration before delivering to the customer. And we're going to do 3 types of testing before delivery: user testing, system testing, and unit testing. So for user testing, we're just going to use the black box method and make sure that, when we input how much kale we have and how much we're using, everything's operating correctly, and at the end of the day, it'll, output the correct amount that's still in the supply closet. And we'll only get to see the inputs and the outputs using this method. System testing, we'll get to see, when the functions operate together. So now we're going to be taking the kale supply and making sure that it's going to automatically trigger the order of more kale when we run low on supply. And we'll only, the gray box testing will only see the data traveling between different functions and not actually what's going on inside each function. And then unit testing, we'll use white box techniques, and we'll make sure that everything is accurately stored in databases, and make sure that all the little parts of the program are operating correctly so that it doesn't cause a large problem down the road. So after all of the features have been tested and we make sure the program is working correctly, then we deliver the final program to the user.
Is there any questions?
You guys, Team Pennsylvania? Texas. Team Texas, all right, so we got Team Texas. All right, so Brian, what role did you play in this?
I was a tester.
Testing, so Brian's testing. Ashley?
Ooh,
Let's start Ashley.
Ashley was the user story scribe.
User story scribe, okay, but Ashley's not here today, right?
Right, so.
Now, did Ashley actually participate?
No,
Ever?
less than what was recommended.
Gotcha, so you reached out to Ashley, no, so let's talk about this. So you reached out to Ashley, you made contact with Ashley, right?
Yeah.
You had meetings. Did Ashley attend the meetings?
She attended the first one.
So she attended the first one, and then after that, what, she was MIA?
Yep.
Gotcha. All right, and, all right, so basically, one meeting she attended, and then poof, she was gone, is that correct? All right, so that's what we want to know, thank you, I appreciate that. Great. Mr. Cipolla, what's your role?
Iteration planner.
Iteration planner, okay. Mr. Fisher? Task scribe. And Mr. Francisco?
I was the user.
User, so you're the user. Excellent. Fantastic, Dylan.
So we misinterpreted what we were supposed to do just a little bit. So I made a required works document as opposed to a presentation. And our project was to create an order tracking system for the Pie in the Sky pizza shop. What it was supposed to do was keep track of everyone's orders that are going through and determine how they ordered it, how they paid, and the most important part of it was to assign a number to each order so that it was able to be identified with the person. To assign a number, we decided on using the first letter of their first name and the last four digits of their phone number for the order number. And it was just supposed to track your orders, tell you what was going through the system, and spit out a receipt. I wrote up a bit of pseudocode, so this is basically what our program was going to do in the English language.
Gotcha. Why don't you take us through it? Tell us what it's going to do.
Alright, so we were going to have the input from a file. Originally was our plan, but we couldn't get the code to work with it correctly, so we just decided to stick with a list. So we read the input from a list, and then for each order, we just stepped through it. And the first thing we did was ask if it was online, or walk in, carry out, drive-through, because those were the four types of orders we could handle. If it was online, send a survey to the customer. Otherwise, just keep going with the program. And the tracking system for each pizza ordered was supposed to see from the list what size it was, how much it cost by bid increments priced for each size, and then for each cheese past one, it's $1. For each topping, it's $1, and for each like double sauce, it's $1. And then going through the order adds up everything together, spits out a total price on the receipt. And then we also there was a part of the program where the most popular parts of business, the most popular pizzas are cheese and pepperoni. So if we got below 5 pieces, we were supposed to send in a request for more to be made specifically for the cheese pieces and the pepperoni pieces.
How many?
Huh?
How many to be made?
10.
Okay.
And we also programmed to handle orders of breadsticks, increment price, determine breadstick flavor, add to order description, and then at the end here, we had to have a timing system. This was never actually implemented. But we were supposed to determine how much time making a specific pizza would make based on the toppings and everything that was on it. And lastly, the payment method, if it was cash, fine to change, everything else just right in, that it was that kind of payment. That was it.
So-
The iteration plan.
So for our iterations, we had, pretty much it was track the order, keep track of the order, record what was actually recorded, like what was ordered. So we needed to make sure like our order numbers stayed with what our people ordered and kind of organized and put it out in that order. So we labeled the first two like as ones, obviously, because they needed to do that most important. And we estimated 5 days for an order tracking number, 2 days for to keep track of the order, and then for our twos, we requested more cheese or pepperoni pizzas, keep track of toppings and sauces on pizza to determine how much time the order will take. But when we did this, we stuck to our priorities, but we noticed that the time estimates were like a little off, so we were able to implement more of these things in a shorter time. And I think that's due to not lack of planning, but overestimating or underestimating our own abilities. And so from there, we kept track of breadstick orders, store method payment program, find a private amount of change for cash payment, sent customers a survey for online payment. And those were more simple, and but total time allotted was supposed to be 25 days of most 5 workers. And the estimated time frame, but yeah, those would be it.
Okay. Yeah, so in order to determine in order to determine how exactly we would be getting it done, we made a flow chart.
I already tried that. It's not working. And we don't have internet. Okay, so, yeah.
I actually don't think we have internet in this classroom. I don't think it has connectivity here.
I'm connected on my phone.
Yeah, I'm connected. Here, we can try
Alright,
hand
we have a
us.
little picture of the flow chart.
If you have a picture of the flow chart, just step us through your picture. That's fine. It's on the side, but we can turn our heads.
can figure something out.
Alright.
They're like, candy, case this time.
Of course, there always is. Hang on. Here, I'll show you how to do this. Hang on 2 seconds, guys. Oh wait, is this in the computer?
Yeah, I know.
Windows button and click the right arrow.
Is it like control windows or? No, it's the Windows.
I don't know, I clicked the button.
The normal with Windows 8, I think it's after
Yeah.
Just rotate the screen.
That's,
Can you do that?
Yeah, like.
Yeah,
Windows,
Control,
and then
Alt,
R, you want to
Control or the right arrow.
I'm holding the Windows.
Yeah,
I'm not sure if that works in LibreOffice.
I think it's a rotate thing.
No, it's a Windows thing.
It's a Windows.
Windows. How do you do that?
Windows and then the direction key.
Oh, with the Windows button in the direction.
well, that's just
That's not-
rearranging
yeah.
the window.
Control Alt arrow key.
Control Alt arrow.
There it is.
Dang, we learn something new every day, I said.
Well,
It's gonna be a long
That's
day when I
enjoying
can't,
this.
when I can't get that to go back.
Is it upside down or is it right side up?
Okay, this is disorienting.
You know, you can probably keep hitting it, and it'll probably keep rotating, right? Maybe? I don't know.
Yeah. Well, actually, it won't.
Control plus.
How it works is it orients the
I'm
screen
trying, man.
based on the way the arrow keys are. So if you keep control alt right,
So
it
depending which
will
one-
keep the same thing. If you hit control
Left?
alt left, it will flip it.
This is very difficult.
We have a suggestion that maybe if you hit Control Alt left key, it goes the other way.
oh,
Okay.
good.
Keep going. Oh, one more.
Zoom in.
One more.
Let's,
Yeah.
I'm just gonna try to zoom in when I'm not upside down.
Oh, I got it,
That's too low quality, whatever.
You
I have
guys,
a flow chart.
you guys know your flowchart.
Yeah.
You can step us through your flowchart.
The flow chart's more or less the same thing as the pseudocode, just in flow chart form.
So obviously, like, the main concern when you're ordering is, the first thing you need to do is, get the name and the phone number of the person and figure out how they're gonna pay for it. And then there were a lot of options for, pizza toppings and whatnot, so those all branch off, when you're going to order the pizza, there's small, medium, and large. And then, you just kind of go from there. There's the 3 types of cheeses, which all branch off, and there were maybe like 10 meat toppings and 10 vegetable toppings. But in our code, I'm pretty sure we just had
Yeah, we
user
just.
input. Right, so the user would type in, and we'll see the code in a second. But after they had ordered the pizza, they could order breadsticks, and there were, maybe 7 different breadstick flavors and 3 different sizes for the breadsticks. So those all branched off as well. And I think one of the last things on there is if the customer had ordered it online, it sends a survey to the customer just for quality assurance, I guess, and asking them how they would rate their experience ordering the pizza place online. I think besides that, there was 4 different ways to order the pizza, and I guess we'll show the code real quick.
We made a list, like, you gave us in that form as a set customer base. And from there, we defined our order as a list within a list. And so we looped for the user inputs throughout the list.
and then added them to the order, but per order number, separated a list within that list. So if you go down one, so we looped functioning of data, we looped for establishing pricing, and then inputs for cheeses, sauces, and below it is
So we had two different functions. The way we set it up for the list that we gave it, we couldn't have a variable size list because there was no way to pull from that and then into something else. There's no way we could like pull from that list, so we just made two separate lists. And in the first list, we listed how many cheeses were on the pizza, how many sauces were on the pizza, and how many toppings were on the pizza. And then we had to take inputs to determine what those were. Then they got added to a separate list and it's printed out at the end.
Continuing at toppings and breadsticks. These for a while, it was going to say for all the numerical variables, but when we came to if we got just characters, then I'm guessing that those are small, medium, large. We ran into some trouble because we couldn't automatically turn a letter into an integer or string off integer. So we had to do some creative thinking and came up with this. And if you go down one more, it's the last page, but it does run, it doesn't run.
It works sort of. It only steps through it once. So right here is taking the first person who had one of everything and asking, or one cheese, one sauce, one topping, and asking them what was on their pizza. It says their name so you know who it's talking about. It would have the order number there, but we couldn't get it to print out just there. And for some reason, it only goes through the loop once, so it only gets one customer. But we did something.
There you go.
And that's pretty much it.
Well, we haven't heard from all four of you. What story are we missing here?
When I was going through the entire thing, there was a lot of errors, and we're trying to figure it out. So I did a few types of black box texting just to see what would come out like from the list. So I just had things print out sometimes to tell whether or not we were getting certain values. It was interesting because at one point I would fix one part of the thing, because before we couldn't get things to a list of lists, we were putting to the order of those. So I had to change some things with the other program. I had to put more brackets around here, so that would make two different lists. And I got the ID number to work, but then something else to fix another column made the ID number not work again. So I was just jumping in and out around the program, trying to make things work completely. And in the end, all we could get was at least one thing to go through without showing any error messages, and the other one we had, it would go through at least like 3, but then a huge error message would pop up. And basically all that really needs to be done is to fix the process so that we print from more than one person, and to implement cost, and then it basically works how it's supposed to.
Gotcha. Now, can your list structure handle if I, order like a meat lovers pizza with like everything on it? Is it gonna be able to expand to handle?
Yeah,
like,
that's
10
why we
different
made two separate lists,
Okay.
because the first one just lists how many toppings you're getting, so that we can pull from there. And then the second list is the order description for each specific order number, each specific person.
What we did
So
is, when we hard coded up here, we put in a number, like for the first one, we did one type of cheese, one topping, and one type of sauce.
So it'll only ask you one time
Right,
for those
but
numbers.
when it works for, say, the second order, if you wanted 2 cheeses, it asks you to input the cheese twice for which kind of cheese you want. And that's what I got that for.
Yeah, and then when you type in the information for these numbers here, the cheeses, it throws them into the order list, and each order list corresponds with each customer.
Which brings up an interesting point, because when you're ordering ingredients for a pizza, does the sequence in which you order them matter?
No.
Okay. But you chose to use a list, which does certainly allow you to order a sequence. Why didn't you use a set?
We want to be able to, because we didn't know much about what to do, we want to be able to pull things out of each section at a certain time and know in order what we're getting. And we used like 2 there, for example, and other types of cheeses, because we were trying to think of a way to do it in order. So that for one person, because in sequence, you can't really call a specific point, because it's all random. And for a list, you can call specific points. So we use that in our if statements to call certain points to protect, whether it's 2 cheeses, 2 toppings, how many sauces, and that sort of thing.
I mean, you can almost use a dictionary for something like that, right? Because that would be cheese and then number of cheeses, right? So you have a key and a value associated with that, right?
Yeah.
So I mean, once again, you have a bunch of tools in your toolbox. You can use whatever works best. You can do everything with a list. There's no question about that whatsoever. But sometimes there's other tools that you can use that might make your life a little bit easier, right?
That's all we had. So,
Are there questions for the halfway program pizza shop? Oh, we got a question.
What if you don't order the pizza, but you want just breadsticks?
Good question.
didn't get there.
Yeah, you could order that, or just.
That was in planning, but we just couldn't crack it out in time.
All you would do is put spaces here until you got to this column, and if you said yes, it will print things from recipes. So you could do it, it just, you need like the actual customer.
Theoretically, yeah, because we have a price set up at Florida, so the price was just supposed to add for everything added to the order, so we didn't add.
Another question?
One question. Obviously you have an unfinished code, but what iteration would you put this into? You have your code right now, but what iteration would you stick this in?
Would probably be the first, because it doesn't have anywhere near all the features that it's supposed to have, but
But it
it's,
has like all the key features.
It's like the ground level, so we just have to work our way up to make sure we do it.
And now, this is part of the first iteration, are you showing what you have done already to the customer? Or what are you going to do? Because, I mean, there's obviously some errors in there, but.
I would say that this is more or less towards like this, first iteration of pizza, and if we were showing the customers, we would definitely ask, is this how you want it set up with a numerical value to define how many cheeses or how many of any question that we have set up in our list. We would also run over, like the setup of the code, how it's played out, and then from there we get a better understanding of how to work for iterations of.
So kind of like a rough draft.
Well, I mean, like, if we fixed it to where we had the ability to go through multiple orders, we could theoretically present it to the customer and just not have all the features that they need, but like the basics, so they could order a pizza with toppings. And, I mean, obviously, if we were to see the flow chart, you can see how many branches off it needs to be when people are ordering, but we have like the basic line for the flow.
Thank you.
Excellent.